what I'm going to do is I'm going to organize what is basically a reasonably gloomy sort of talk under the heading of I'm first going to talk a little bit about the notion of ecological footprints and how they vary from country to country and the uncertainties in estimating them and what they say. I'm going to do that very briefly as a background then to doing various things. First of all, I'm going to talk about how the human population has grown and some of the other less appreciated aspects of it, the shift from rural societies to being largely urban and other related things. And against that widened background, I'm then going to focus on 4 particular topics, all of them in rather telegraphic fashion. I'm going to talk a little bit about disease, both in the context of human history and about its relationship to new and re-emerging diseases. I'm going to, and all these 4 interplay. I'm going to talk a little bit about climate change, which these days doesn't need much talking about, although next Monday, Nicholas Stern, who was the chief economist at the World Bank and is now the second permanent secretary in the Treasury and is a person who spent most of his life in the developing world and is a very unusual economist in that he doesn't believe in a set of fundamental mathematical bits of dogma that say free markets cure everything and so on. And instead of believing in this fundamental religion that tends to pass for most of economics, he's actually interested in, as he said of his task, it needs all the economics that exists in academia and a great deal more. He's going to produce a report on what we should be doing about climate change, how much it's going to possibly cost, what are the costs of various options, and what are the sort of benefits to those costs. Then it's going to be a more realistic and unpolitically coloured thing, which I expect to be really the best study yet of that kind. I'm not going to talk about it, and I'm not going to talk much about climate change beyond that. And then I'm going to talk about future food supplies and water, and I'm going to end by moving from the anthropocentric focus of most of the talk to talk about the other creatures or the other organisms, plants and animals with which we share the globe. So first I'm going to define what I mean by, I find this theatre is a great theatre, but it's curious. You're all in the dark and I can see the slides. And I notice I'm in the habit, I see myself, instead of looking at you, looking at the slides all around me. But anyway, I'm going to define what I mean by ecological footprint, and that's it. And I assume everybody can read, so I'm not going to follow the conventional academic, rather irritating habit of putting up words and then reading them. I assume you can read them at least as fast as I can. And the result of that, I have to tell you, it's an interesting idea, but it's a very dodgy calculation. It's a very imprecise calculation. You could argue about all the components in it. And some of it is estimates of how much humanity, different intensities in different parts of the globe, how much land it needed to grow its food, fishing, forests, just that little strip at the top to build stuff where you wanted to live, and the most imprecise of the lot of the amount you need to preserve or use for forests to help keep the carbon dioxide balance. And that's really a very controversial part of this estimate, actually. But nonetheless, with all its imprecisions, you at least get something that gives you relative impacts country to country in a fairly realistic way. And this is really, I think, very interesting figure that some of you will be familiar with, some of you not, that shows the average ecological footprint in units of area cast by, from your left to right, the average inhabitant of North America, which is mainly to say the United States and Canada being small, Western Europe, where the average footprint is half that of the United States, and down through other countries to this extraordinarily large swathe of stuff, Asia Pacific, which is mainly India and China, and that's the height gives you the average footprint per person, and the width tells you number of people. So you see North America has double the footprint of the next most profligate group of people, but at the same time there are so many more people in China and India that already their footprint is larger. And nested within this, well, first of all, you can also estimate by the same imprecise calculations, so some of the imprecisions cancel out in the comparison, what is the human footprint that the globe could sustain in a sustainable, continuing way. It could sustain it by having fewer people casting bigger footprints or more people with fewer footprints, but that's the total footprint that could be estimated to be sustained. And you put that against the actual footprint, and by that estimate we exceeded that about 15 years ago. The precision of this calculations by WWF, it's an interesting idea. The precision of the calculation is you can't really take it too seriously to within 10 or even 20 years. But what you can say is that for the first time, the magnitude of our footprint rivals the natural processes that built the planet as a place in which we thrive. And there are various other ways that you can express that, quite independent of this WWF estimate. And here are three related ones that I think are particularly dramatic. One of them, which goes back about 15 years, an attempt to estimate how much of the land area we use for our purposes, directly or indirectly. And the estimate is often given as 40%, although I'd prefer to acknowledge its imprecision and say a quarter to a half. But it's on the scale of half the land area. Interestingly, just in the last 12 months, a much more high-tech version of that has appeared by using Landsat imagery to actually ask what fraction of all the land surface area of the globe bears the mark of human management rather than natural. And the answer to that, by what I think is a coincidental agreement with the earlier thing by people at Stanford, is 40%. To my mind, the most dramatic single figure is the estimate that more than half the atoms of nitrogen that are incorporated into green plant material last year, more than half the atoms of nitrogen incorporated into green plant material, and also, separately, more than half the atoms of phosphorus came from fossil fuel energy subsidized fertilizers rather than from the natural biogeochemical processes which built the biosphere. That's an extraordinary statistic. It's because green stuff, plants that eat photons from the sun and are the basis of all other life, the most important elements far and away are hydrogen, carbon, oxygen. It's the basic thing of oxygen and, well, I won't go into it. But then the next two after those big three are indeed nitrogen and phosphorus. Then that's an extraordinary transformation which sets the scale of our activity. Nested within that earlier thing I showed you of different footprints in different places are some interesting ethical paradoxes which I just offer to you without further discussion. Oddly enough, the Swedes, whom you would tend to think of being virtuous, in the league table of big footprints, the top five, I really regret to tell you, are first of all the United Arab Emirates, not surprising perhaps, then the United States at 9 units, then Kuwait, then Australia at 7.5 units, and then the seemingly virtuous Swedes at 7 units. On the other hand, the average Swede, although casting a big footprint, casts a footprint smaller than their country could sustain. So how does that make them for virtue relative to the average inhabitant of Egypt, who casts a footprint 3 times what the current country can sustain with its current population, while at the same time having a footprint less than a quarter that of a Swede? But the one thing overall is the world average footprint is a good deal less than that in the West, but exceeds the sustainable estimated limit. And that's largely as much because we're more people. I mean, it's a mixture of more people and differently in different places, but all of us, even in the poorer places, having a bigger impact, consuming more, putting more stuff into the atmosphere than hunter-gatherers did. Most people think the population got to this point by a steady exponential rise. Nothing like that. For most of our couple of 100,000 year tenancy of the planet as hunter-gatherers, human numbers probably were in the range 5 to 20 million. You can't sustain many more humans in the hunter-gatherer mode. It was about 10,000 years ago with the, as it were, invention of agriculture, which very rapidly led to settlements and then to small cities and then bigger cities. At the dawn of that agricultural revolution, human numbers really took off. And interestingly, the first half of those 5,000 years saw a faster rise in population than the second half until recently. And that's largely, as we'll see in a moment, because as humans came together in denser aggregates, they were able to maintain infectious diseases that hunter-gatherers are too sparse, and to also, before their domesticated animals, didn't quite have the interactive sources to acquire and maintain. Then came a second transformation with the dawn of the industrial scientific revolution, the revolution that went beyond philosophizing about how the world may work, which is something we've always done, even when we were hunter-gatherers. Goodness knows people have different interpretations of what people were trying to do, painting things in caves, but you can be pretty sure they were trying in a rudimentary way to make sense of the world. We often say the Greeks began to invent science, or the early Arabs with mathematics. Mathematics is different from science. It's more logical structures. It's, if you say two sides of a triangle are equal, then you can prove that two angles are equal. And that's just a fact. You just do it by thinking about it. And it leads down the rather perilous road of thinking you can understand the world just by thinking about it. And that's what we did pretty much, with a few exceptions, until a few hundred years ago. Even the great progenitors, people like Aristotle and so on, were people who thought they could work it out by thinking about it. And it was still a very authority-based world. And some of the authoritarian things that were believed, like heavy objects fall faster than light ones, had a kind of resonance that you didn't question lightly. So, for example, one of the things that Aristotle had said, Aristotle didn't believe, he had a different version of what the blood did and it didn't circulate. And Thomas Aquinas had really then canonized that as part of official Roman Catholic dogma. So when the person before Harvey, chap in Spain, wrote a book suggesting that really the blood circulated, you may think that people today distrust science or don't like it, but what happened to that bloke? He was burned at the stake with his book tied around his tummy. With the invention of the notion that you ask questions about how the world really is, you climb up the Tower of Pisa and drop a heavy thing and a light thing, which is pretty revolutionary. You end up spending much of your life under house arrest as a consequence of going that way, as Galileo discovered. But with the invention of the notion that you do experiments and you ask what actually is there to test your thinking, there was a dramatic acceleration in our understanding of the world that is still accelerating. We've learned more about how the world works in the last 50 years than in all human history previously, and it's still accelerating. And that's a different talk I'm not giving, because that's the talk that leads to say how important it is that you have an organisation like the British Association that bring people together to think about how we use that understanding, how we try to guard against the unforeseen, unintended consequences of our well-intentioned applications of our knowledge, so that we build all sorts of energy-saving devices and then discover we're changing the climate. And we make everybody healthier without thinking about what it's going to do to population numbers, and then discover we're eating ourselves out of house and home. That's a science in society kind of consequence I'm not going to talk about, but it's an immediate consequence. It's a corollary of this talk, but I'm just going to go back to my gloomy talk. And the third great phase of human population growth has occurred just in the last 50 years. In fact, if you look, it's nothing like exponential. In fact, somebody once did fit a power law to it and discovered that the human population was going to be expanding outward from the planet at the speed of light somewhere toward the end of this century, if you projected this in a naive way. It took us all of human history to get to the first billion around 1830, doubled it in 100 years, doubled it again in 40 years, and today we're about, well, that slide's out of date, we're about 6.4, 6.5 billion, and we're committed to 9 billion by the middle of the century. Nested within that too are some, well, first of all, nested in that are two other really surprising things that make this particular moment in human history really remarkable in two respects. One of them is, although we haven't been growing exponentially, with little fluctuations from things like the Black Death and so on, human numbers have been growing. On average, each woman has been having more than one female child, certainly since we started inventing agriculture 10,000 years ago. Just in the, maybe last year, maybe this year, maybe next year, we're actually going to go through a transition point where, as a global average, the average woman has fewer than one female child. Most people don't realize that. Population numbers are still going to grow because we have an age structure in the most populated parts of the world where most people are under the age of 25, and even if they have not enough to replace themselves, they're still going to add half as many again as are here today. So the projection that we'll have half as many again, 9 billion, by the middle of the century, barring catastrophe, is entirely consistent with the fact that we're beginning to see a demographic transition, but it's switching in very slowly. Oh, no, sorry, back to this one. The second remarkable thing is, again, maybe last year, maybe this year, maybe next year, maybe in London, maybe in Lagos, a child was born that marks the fact that for the first time in our history, more people live in big cities than live in rural areas. But all the roughly 3 billion, half as many again, we're going to add by the middle of this century, are going to be added in urban areas. And that's another remarkable change. You go back to the 1700s, 1 in 10 lived in cities. 100 years ago, it was a quarter. Today, it's a half, and by 2050, it'll be 2/3. Number of cities, is, for example, with populations more than 1 million has grown like that. And if you actually make a table of what are the league table of the biggest cities, first of all, it's a bit tricky because it depends a bit on definition. So there aren't any Chinese cities there because it depends a bit on definition, that you call Tokyo the larger aggregate and you don't do the same thing to Shanghai. So this is not like so many of these things that has imprecisions. But the most interesting thing about it, I think, is it shows that there are big cities and big cities. Tokyo has been the world's biggest city since 1700. For 3 centuries. And it's a remarkably livable place. It's growing slowly. It's adapted to what it is. But look at Lagos, for example. Less than 2 million 30 years ago, or 10 million today, and it's going to double again in the next 10 years. That's unimaginable. And it's a chaotic shambles. It's no two ways about it. On the other hand, there are real differences between the slums in most of these new megacities and those in the West as it industrialised 150 years ago. So, as you can read, mortality rates in Britain in the middle 1800s are something you just can't relate to. There's a survivorship curve for Liverpool in the mid-1800s. Half of all the children born in Liverpool then did not survive to the age of 5. I don't have a slide that has, and I should have, and I discovered I didn't put in a slide that has the developing world 50 years ago. The developing world, and another one again, that infers from remnants in caves what was the survivorship curve of hunter-gatherers. By survivorship curve, I mean it's a curve, you could do it for birds or frogs or humans, and it's the probability that having been born, you'll live to be 20 years or 50 years or 70 years. If you did that for humans 50 years ago in the developing world, you'd have got a curve that wasn't as bad as Liverpool 150 years ago, but still was, and in fact hunter-gatherers were much like Liverpool. The developing world was not a lot better. By contrast, the developing world today, although the death rate is still, the infant survival to the age of 5, is still in the range 6 to 10% mortality, which is still disgraceful. It's nothing like the West when it industrialised. And that again, and it's a thing that's not fully appreciated, as we feel bad about the fact that there are still such disparities in the world. At the same time, we really do need to remember the changes that have come about as the result, not of high-tech Western medicine, but of simple understanding of infectious diseases that have come out of the Western Enlightenment age. 50 years ago, the average life expectancy at birth on this planet was 46 years. Today, it's 64 years. One particular example, the average life expectancy in India at birth 50 years ago was 34. Today, it's 66. And that's nothing, it's not high-tech, it's just better understanding, better hygiene, better understanding of transmission and causes of infectious disease, rehydration treatments for infant diarrheas, to a certain extent vaccination programs, and that has been responsible for this huge upsurge in human numbers, but it isn't a pattern like our own past. Whoops. There are other differences that are not appreciated in some of the well-intentioned things we do, and again I let you read this rather than read it to you. The earlier slums were things like Liverpool that drew people in, but then as industrial prosperity rose, eventually you get today's Liverpool, which is great, and where the decayed centre is revitalised, and unfortunately a lot of it is expanded outwards into sprawling suburbs, but it's nothing like the last century. The notion, there are some places in today's developing world that are like that. For example, China, where industrialisation with all its downside is having the same effects of enhancing individual lives. But there are lots of other places, Lagos would be one of them, in sub-Saharan Africa, in parts of the Middle East and Latin America, parts of Asia, where urbanisation is just, in a sense, a dumping ground for the disenfranchised. So instead of being a focus of growth, it's become something where people work in unskilled, unprotected trades, and the well-intentioned International Monetary Fund, governed by its fundamentalist beliefs in certain economic dogma, tells these people that they've got to do things which are based on the assumption that what is being seen in developing world cities is like what was seen in Liverpool 150 years ago. And arguably, seeing as it isn't, demonstrably isn't, that's a fact, arguably also it means some of these programs actually are quite perverse. And for those who would like to see that developed further, I recommend the most recent book by Joe Stiglitz, the recent Nobel Prize winner, previously faculty member at Princeton, and previously chief economist, two back from Nick Stern at the World Bank. And it's an excellent development of what is the good things and the bad things about current beliefs about free markets and stuff. So now I've finished with, if you remember my agenda, which was to say some things about population history and so on, and then against that turn to four specifics: disease, climate change, food, biological diversity. So coming back to disease, I touched on that already at the beginning. And this is a quote from a recent book on development of cities, which expresses itself very well. And it points out, as it amplifies the statement I made earlier, that bacteria and viral diseases, mostly, to maintain measles in a population, you need a population of at least 1/3 of a million people living together. So a country like Iceland, which is not big enough, before vaccination, it would have little measles epidemics every now and again when you'd had a whole set of people born not exposed to measles, but it couldn't maintain measles in Iceland because there just weren't enough people. But with the rise of cities, you could. And nearly all the childhood diseases we're familiar with and that killed kids in Victorian times came and were not present in hunter-gatherers, but they came from animal-human contact, particularly domesticated animals. And you can document some 300 diseases, things like influenza, smallpox, and measles, that have taken such a route. These days, in the developed world, there are those who feel that these kind of diseases are a thing of the past, and the most remarkable statement to that effect, whoops, I've lost the, sorry, I've done something bad here, I've lost. The most remarkable quote to that effect comes, this in my opinion is the most stupid prediction ever made. There's quite a competition for making the most stupid prediction, it really is. And there are some really great wrong predictions. I must say one of the most embarrassing, and always something that I kept in mind when people ask me to make predictions, yeah, I'm just telling you how it is, not what's going to happen, is 100 years ago, if you'd wanted to think about the future of aviation, who would you have asked? You'd have asked Lord Kelvin, the greatest fluid dynamicist of his age, president of the Royal Society, and Lord Kelvin would have said to you in 1896, on the basis of all the work he'd done on fluid mechanics and stuff, he would have said to you, heavier than air flight will always be impossible. 7 years later, the Wright brothers flew. This, however, beats them all. First of all, it was an incredibly ignorant thing to say just because a set of things had been looked after, to think there was no new things were going to come. But even worse, this is one of the most egregious examples of American exceptionalism that I know. You know, Americans weren't getting infectious diseases, never mind the rest of the world. Close the book. So where was I? Well, a few years later, poor Mr. Stewart, Dr. Stewart, who was no longer there, retired. I don't know whether he's even still alive, actually. Truth came home to him, and more recently we are familiar with the still growing epidemic of HIV, still growing as we speak, but not commonly on your telly screen because it's rather boring, there's no new news about it, it's just happening. SARS, we were lucky for rather technical reasons. Who knows what will happen with bird flu. Most of these things, and this is a point that's not too commonly emphasized, these also come from our interactions with other animals. This is a map of with the rising prosperity in southern China, there are now what used to be a traditional small practice of people in forest villages of eating exotic things they could kill in the forest. And you can see that that has been around for a while. Many of these traditional hunters actually have antibodies to things like SARS. But it has become globalized and internationalized and scaled up to serve exotic animal restaurants for well-off people in southern China. So SARS is which we were lucky with, as an explicit example of something that came from animals as an explicit consequence of the bushmeat trade. But for that matter, and I must have skipped past the slide as I was losing track of where I was, HIV 1 is from bushmeat eating chimpanzees and HIV 2 from macaques. And that's fairly unambiguous by now. And here is some rough attempt. There's very little work on this. The very good set of people who do this even have a bit of difficulty getting it published because it's, on the one hand, it's hugely important. On the other hand, it's hard to be precise, and if you send it to a second-rate journal, they will look at it with pedantic rigor rather than asking, was it really interesting? Forgetting one of the other great quotes of science from the person that many think was the greatest statistician of his generation, John Tukey, who once said, far better an approximate answer to the right question than a brilliantly exact answer to the wrong question. So here's an imprecise estimate of the upsurge in the bushmeat trade. Before I come back to talk about biological diversity, I just want to say a quick word or two about climate change in relation to these other things. This is just one of many pieces of evidence that could be displayed in this context. It's a slightly controversial, in fact, I could preach a whole sermon just around that and the attacks on it and so on. But basically, what it shows is an estimate, mainly from ice core data, of the fact that there's natural variability in the climate, has been for the last 1,000 years, actually has been for the last 10,000 years, but what we're seeing now is right off scale. We only have really good records of the hottest year for the last century and a half, but all 10 of the hottest years in that century and a half have been since 1990. More generally, a lot of people still find it difficult to relate to this problem for understandable reasons. People tell them the planet this century, in a way that's closely correlated with the increasing inputs of carbon dioxide from burning fossil fuels, has warmed up 0.7 degrees centigrade. And it looks, and we're not sure, but a very sort of a precise statistical ensemble average of different approaches to modeling it with much greater precision than any prediction in economics, suggests that over the century we're going to see warming of somewhere between 1 to 2 degrees or 6 to 8 degrees, somewhere in that range. Well, that doesn't sound very worrying because the temperature tomorrow is likely to be 2 degrees warmer or colder than today, so who cares if the temperature fluctuates a few degrees? It's very hard to relate to the fact that there is all the difference in the world between the temperature changing 6 degrees from day to day and a 1 degree change that is sustained year after year after year. And to put it in perspective, I would say, although it was colder, not hotter, the average global temperature at the depth of the last ice age was 5 degrees on average lower than today's average temperature. Not a lot in a world where we here were under several, better part of a kilometre of ice. And the last time the world came to equilibrium, with a greenhouse gas blanket as thick, 500 parts per million, as we're looking at by the middle of the century, was 20 to 40 million years ago. And although you don't worry much about what you hear about ocean rise, it's a few centimetres, who cares? When the Earth came to equilibrium with that greenhouse gas blanket, the oceans were 100 metres, 300 feet higher, because the time scale for these things, apart from anything else to unfold, defies the intuition you have from everyday things. You put an atom of carbon dioxide into the atmosphere, it stays there typically for a century. And the warming effect that that thickening blanket has on the oceans penetrates, the warmth penetrates very slowly to the deep ocean. So it takes characteristically more than a century for the ocean to equilibrate with the thermal expansion from the warming. That's quite apart from other considerations of a more potentially non-linear and slightly more unpredictable character, such as melting the glaciers, changing the reflectivity at the poles as the ice melts, and so on. So without going on and on about this, I would just observe that for those who aren't knowledgeable, don't know this, in connection with the G8 summit in Britain last year, the science academies of all 8 of the G8 countries, United States, Britain, France, Germany, Japan, Italy, and Canada, together with China, India, and Brazil, produced a statement that said very simply, climate change is real, it's caused primarily by human burning of fossil fuels, and its consequences are really serious, and small actions now in a system like that are more important than big actions later. And here is a sense of the scale of the problem we're looking at today. This chart shows the way we get the primary energy of all kinds that we use, and then more explicitly electricity. And you'll see that the energy sources we use in transport, in home, in the marketplace, at work, the energy sources we use are essentially 80% from fossil fuels. Fossil fuels are essentially yesterday's sunlight, fossilized, and now we're releasing that energy that the trees captured tens, hundreds of millions of years ago. Currently, we burn, in 1 year, 1 million years worth of fossil fuel accumulation. And it has good effects in many ways. It subsidizes the fact, the energy, or 80% of the energy that is, I've lost that sentence. The average human today, and very differently in different countries, subsidizes their daily activities to the extent of 14 times the energy you need just for metabolic processes. And 80% of that is fossil fuel burning. It's different in different countries. The average inhabitant of the United States puts 5.5 tons of carbon into the atmosphere each year. The average inhabitant of Western Europe, 2.2. The average Chinese, 0.7. The average Indian, 0.2, and others less. But overall, in average, the average American, it's more like 50 times metabolic process. There'll be people in other places where it's a few times, but for all, it's quite different from hunter-gatherers. And although sociology texts will tell you it's all sort of brouhaha that changed our values, the truth of the matter is that the invention of these energy subsidies is the primary cause that has washed away hierarchies of servitude structured as class structure. It's the fact that you didn't need servants anymore. Of the remaining 20%, globally, and it'd be mainly in the developing world, 11% is biomass. Most of that is deforestation. It is not sustainable growing the stuff in a way that first it uses the CO2 and then it re-emits it when you burn it. And there's only 10% that's really renewable, and rather unhappily, particularly for those who see very clearly the problems with nuclear and see the problems with nuclear as somehow vastly greater than the problems with other sources, whereas others would argue each have their own problems to be addressed, and at least nuclear energy isn't cooking the planet. But of the renewables, 2/3 of it, namely 7 of the 10 percentage points, is nuclear, and globally, the sum total of everything, hydroelectric, geothermal, wind, wave, water, is 3%. So we've got a hell of a lot to do. Particularly interesting is oil, and it's particularly interesting how much oil, though it's only a smaller fraction than coal, that we use in electricity. Oil is the thing that drives all the world's transport system these days, cars, planes, boats, everything. And it's going to run out first. And many people think that's a double whammy, that's really bad. First of all, you know, we're burning the oil, and secondly, it's going to run out. My own view is it's great it's going to run out, because on the one hand, we're burning oil as like the other carbon fuels. Nobody wants to be the people doing anything about it, but once the oil starts to run out, it's really going to get people's attention. And when it does, people will ask, why in the name of all things strange did we take this particularly convenient form of energy and use it to generate electricity when we could have done that so many other ways? Once again, there is a real difference in different parts of the world. If you look and you ask, how is the wealth of the world distributed? You see that the rich countries, and I've put the developing world into the poor and the transitional ones, so India, China would be transitional. The rich countries represent little more than 10%, about 1/6 or so of the world population, but they have half the GDP, and they're responsible for half of the industrial energy, and they're responsible for half the fossil carbon that's being put into the atmosphere this year. 6/7 of the world's population, but half the inputs. And nearly all the stuff that's there already, and remember it's resident for a century, nearly all the stuff that's there already was put there by the rich countries, which puts in perspective the arguments that are made by some that the US isn't going to do anything until China is doing something too. Of course China and India have to be doing things too, but there has to be some recognition of equity in the targets that are set among countries. Very quickly, where am I? I'm in kind of reasonable speed. Food. Here again, good news and bad news. In the last 35 years, global food production has been doubled. And it's been done on only 10% more land, which is just as well because, as we saw earlier, there isn't all that much more land. At the same time, the global population increased only about 60%, so there's more food per capita, and insofar as some people are malnourished, it's a problem of inequitable distribution. That's not a trivial problem. That's been with us for the full 10,000 years of the agricultural revolution. It would be nice if we could solve it. So that's great. We're feeding the people we got now. Admittedly, to do it, we've had to increase by 7-fold the amount of nitrogen fertilizer, and we saw that earlier. So make no mistake about it. We couldn't be feeding today's population with yesterday's agriculture. On the other hand, there are signs that those advances, which again are based on clever production of new kinds of crops, high-yielding rice and so on, but with the downside that these high-yielding crops need lots of energy subsidies in their growth. So what we really need is a sort of doubly green revolution that is even cleverer, and I don't see how we're going to do it without using very precise techniques of crop breeding, something we've been doing for 10,000 years, but doing it more precisely than the shotgun approach we've been using up to this point, by actually deciding what are the genes we want to put in and putting them in, instead of doing what we've been doing for 10,000 years in an increasingly technical way. But most of the things organic farmers grow are things that have been produced by reshuffling the genome in unintended and uncontrolled ways. Typically, when you make a new strain of crop, you reshuffle about 1/10 of its genome. So I think we've got to learn to do that more precisely to get things that are actually grow, that are designed to grow in the environment they have, rather than doing what the Green Revolution and most of our agricultural revolution has done, of taking the crop and then wrenching the environment to fit it with fossil fuel energy subsidies. In doing that, we've also got to learn to use less water. Here's a pattern of the global increase in water use. It's mainly used for agriculture, differently again in different countries. But if you look in detail at how this has affected available water, combination of water you've taken by mining aquifers, which is not always a sustainable practice, and the water that falls and that you catch in catchment areas. If you ask the light-shaded countries that use less than 10% of the sustainably available water, and it goes up to the countries in supra-Saharan Africa and the Middle East, where by and large they are currently using, across that dark red swathe, more than 100% of the sustainably available water, just to say they're mining aquifers. But most of India and China are not in frightfully good shape. So today, something like 30 countries with a little less than 10% of the world's people are actually in a water deficit. But the projection is that in about 20 years, that number is going to increase to roughly a little less than half the world population will be having problems with water. And here's one estimate from the Wallingford Centre of people who work on these things that could be wrong. It's projecting, and maybe things will dramatically change, it's projecting the trends we just saw in demand ever upward as the developing world begins to move up its footprint. And it takes account of the fact that with clearing watersheds and various other forms of pollution, we're actually having loss of water available. And it asks when those curves cross. When the curve of globally available water, never mind local inequities of surplus and deficit, when the global supply intersects the global demand. Like all these things, that's wildly imprecise. There are many reasons why it could happen 20 years later or 10 years earlier. But it again is yet one more thing that sets the stage for the uniqueness of our time, when the things we're doing are on the scale of global natural processes. And we're just going to have to learn to use water more efficiently and use it perhaps to grow a different selection of things and not be too extravagant with the things we do use it for. And finally, biodiversity. This is a corner of the Bronx Zoo, which has a series of tombstones, which I'm afraid with the slide that's scanned into the PowerPoint is unreadable. It's a corner of the Bronx Zoo with tombstones for certified extinct animals. And you're going to have to take my word for it, they're all birds or mammals. They're the rufous gazelle, the Hawaiian rail, and various other things. And it's a rather evocative corner of the zoo. It was actually done by one of my ex-students who was the director of the place. We actually don't know much about how many species are going extinct, and there are many of my colleagues. There's a rather daft estimate that was done by convolving some certain technical ecological rules about how many species on islands of different size with some rather, in my opinion, exaggerated version of how many species there actually are, that people are in the habit of saying 27,000 species are going to go extinct this year. Two-digit precision. Well, as I shall explain in a moment, nobody has a clue how many species are going to go extinct this year, but it's most unlikely to be that big. And it's a very foolish thing to say, because you're vulnerable to someone in the audience saying, as I heard someone say to one of these friends, would you name one? The fact is, we simply don't know, to within about 10%, how many distinct species of plants and animals have been named and recorded and known to science. They're there in different museums with labels, but they've never been collated like the books in a library. And because the most numerous group is beetles, about 400,000 beetles, about arguably 1/3 to 40% of them are known from only one collecting location. So it's not surprising that the same species has been found over the years by different people, and people haven't yet collated things to work out the synonyms. So about something like 1.8, 1.9 different names have been given, but the sort of mathematical study of trying to resolve empirical and mathematical, because even as you're resolving old synonyms, people are creating new ones, suggests that it would, a sensible estimate might be 1.5, 1.6 million different plants and animals. But we don't know to within 10%. But that's the ones we've named and recorded. We don't know to within a wide margin how many different species of plants and animals. I'm leaving out viruses and bacteria, they're different. A plausible range would be somewhere between 3 million to 10 million. Between twice as many as we've named and 6 times as many. But people have suggested much bigger numbers. We're adding new ones to the library of the known at the rate of about 15,000 a year. So even if you took the lowest possible estimate of twice as many, it's still going to take us a century to do it. So it's not surprising against that background that what we do know, we know the birds and the mammals and some of the really quite well. We still find a new bird or mammal species, a few of them each year, but we know them pretty well, about 10,000 birds and about 4,500 mammals. But insects, we really don't have a clue. We know about 1 million. They're the most numerous group. If someone gives you something and asks you, what is it? Say it's an insect if it moves and a plant if it doesn't, and you've got 3 chances in 4 of being right, because 2/3 of things are insects. On the other hand, against that imprecision, we can actually say some quite precise things about extinction rates. And we can do it by saying if birds and mammals, which are reasonably well known, are typical, then we know about 1 bird or mammal species a year went extinct last century and has a tombstone, a certified extinction in the Bronx Zoo. There have probably been more extinctions, so saying 1 a year is a conservative estimate. That's a group that's of the order of 10,000 species in total. So if 1 a year goes extinct, if you're one of those species, it's if you're playing a game of Russian roulette with a revolver with 10,000 chambers and 1 bullet. And you play that game, your life expectancy is of the order of 10,000 years. And you can now ask, what is the life expectancy in the fossil record of the average bird or mammal species? And the answer is, with a lot of variability, and it's true of all sorts of other organisms, a lot of variability within and between groups, but it's of the order of 1 million to 10 million years, sometimes shorter, sometimes longer. So if birds and mammals are typical, over the last century, extinction rates have speeded up somewhere between a factor of 100 and 1,000. And then there are various lines of argument I won't inflict upon you, some general, some specific, that suggest a further acceleration and shortening of lifespans to more like 1,000 than 10,000 years, so that with an imprecision of a factor of 10, you can say, if birds and mammals are typical, and there's no reason to believe they aren't, the extinction rate spasm we are seeing and experiencing is an acceleration of somewhere between 1,000, maybe only 100, maybe 10,000, but characteristic of order 1,000 times the average background in the fossil record. And that is what characterizes the big 5 episodes of mass extinction in the fossil record. This one, number 3, is the thing that was the really biggest and marks the separation between the Paleozoic, the old age of life, and the Mesozoic. 5 is the one that did in the dinosaurs. And we are, make no mistake about it, we are standing on the breaking tip of a 6th great wave of extinction. And it's different from the others, which are external events. This one is a mixture of habitat loss, over-exploitation, moving things around and getting alien species in new places, usually a mixture of 2, sometimes all 3. And it's going to unfold slowly. It's not going to lose half the species this century. It's going to unfold slowly, as most of these others did. Slowly, on our scale, the blink of an eye on the geological scale. And climate change is an extra whammy in that. And as we try and address it and try and plan schemes of triage of what we'll save and what we won't, we have a problem that where the proportion of endangered species, and there are conscientious lists of endangered species, and here's another amusing set of statistics that exemplifies how we know different things about different groups. If you ask, of the named and recorded mammal species, how many are certified in the various categories of threat, reasonably precisely defined? I mean, they underpin what customs officials confiscate at airports, and so on. And the answer is about 1 mammal species in 5, 20%. Then you ask a slightly different question. You say, of the mammal species, that's of all mammal species. You say, of the mammal species that people have had a careful look at, what fraction are threatened? And the answer is 23%, because most of them have been looked at. Then you ask about fish, which of the vertebrates are the most endangered, because particularly freshwater fish with pollution of rivers are great trouble. If you ask what percentage of known fish species are on the endangered list, the answer is 3%. Then you ask, of fish species that have been evaluated for category of threat, what fraction are threatened? And the answer is about 1/3. And of course, that's again a difficult statistic because you probably evaluated differentially the ones you thought were endangered, but nonetheless, it's indicative. But here comes the really good one. What fraction of all insect species are listed as threatened? 0.06%, 6 species in 10,000. What fraction of insect species that have been evaluated for conservation purposes are classified as threatened? 3/4. Or another amusing one. Nearly half of all the animals with certified extinction certificates are birds and mammals. Plants and animals. Half are birds and mammals. There are 72 insect species that have been certified extinct. 43 of them are Hawaiian Drosophila. That's a byproduct of the genetics industry. Only 8 are from continental areas, 1 from Germany, 7 from the United States, and not a single one is a tropical mainland insect. So we don't know a lot about it, but even under that imprecise categorization, you can see that 2/3 of the threatened species belong in countries where the average GDP per capita is is about $600 or less, whereas the well-off countries account for less than a fifth. And this brings me to my last slide, which is a classification in how we're trying to distribute resources so that whether it is new and emerging infections, whether it is coordinated activity against climate change, whether it is worrying about redesigning an agriculture for tomorrow in relation to water and other things, or whether it is giving some respect to the creatures that share the world with us, how are we going about redistributing the resources to develop the infrastructure to at least work on these things and bring the developing world not up to exactly what we do, because there just aren't enough resources to do that. That's any economist who thinks these things just obey formulae as if they were mathematical abstractions. I mean, the notion that China's footprint will rise to be the same as the United States can only be held by somebody who has certain properties that seem to me to border on mental retardation. But you ask, how are we doing in our attempts to bring a certain amount of equity, and it'll help build, amongst other things, scientific endogenous capacity in the developing world, better than it is? Well, there is a commitment, as you know, in the OECD countries to put 0.7% of GDP to aid to developing countries. And here's the league table of how people are doing on that as of a couple of years ago. And not surprisingly, there's some Scandinavian countries, and Luxembourg and the Netherlands are actually meeting the goal. There is us down with Australia and Germany, a little less than halfway there. And interestingly, who's at the bottom? I don't offer, you will have noticed, any solutions to this. I just think partly we need to see the problem clearly. We clearly need to do more than that. And I always bear in mind, and some of you may even have heard me say this before, so wonderful phrase that Joan Didion used of V.S. Naipaul. As many of you will know, a person whose Nobel Prize for Literature came very late because he angers many in the developing world by the clarity with which he looks at their problems, which is often very politically incorrect, not to say offensive. And she said, he looks upon the world with an icy clarity beyond regret or hope. And my feeling is that's not enough. It's very tricky. It's not enough just to look on it with sort of sentimental mush and have concerts with aging stars and stuff. You need the combination of the clarity to see it as it is, but that's not enough. You'd have to have the regret for what's being lost and the hope that you can do something about it, or all you're doing is describing a disaster. But the description is part of it, and I think one should never forget that.
Have you seen Al Gore's film about climate change, and if so, what's your opinion of it?
Well, my opinion of it is the same as I always had, which is I always did feel it was a tragedy not just for the United States but for the world, that the fact that he won the presidential election 6 years ago was not reified by the courts that acted like a banana republic. The notion that you elect, well, I mean, I think it is the film itself as a powerful thing, and it's great that there is. The States is very complicated because it's almost two countries in many ways, and it doesn't divide simply into Republicans and Democrats either, because you have California with a Republican governor that is actually more down-to-earth activist in many of these respects than we are. with a government that is committed, and I believe genuinely committed to doing things, and genuinely sees the problem, genuinely provides leadership internationally, but chickens out on doing difficult things at home. So it stands back from the nuclear question and lets the amount of nuclear energy on the grid go down from 30% to 20%, losing the capacity to be an intelligent customer for, and to deal with the problems which are real and worrying. It evaded that debate. And so it goes with other things, and indeed our own position with climate change. The Kyoto target, as you know, for Britain was 12.5% of 1990 by 2012, and we're currently at 12.6, so we're under the target, and we're not there. But if you look at it in more detail, the switch to gas brought us down below that, and in the last 3 years we've been going back up again, so we got well under 12, and at the moment we're going to have to try fairly hard to get back on course to meet the Kyoto target, never mind the 60% additional that we promised to do. So coming back to Gore, it'd be very, if Gore were by some, even if Gore had been elected, whether the excellent job he's done of portraying the message, he would have been able to translate into effective action is a very interesting question.
Do you think that nuclear power is a practical alternative to gas for electricity?
Yeah, I mean, nuclear always has had the problem of waste disposal, and now it has the additional problem of terrorism. So it has really serious problems. But given the part it plays in power generation that doesn't contribute to global warming in Europe, I have difficulty seeing how we're going to not go beyond 500 parts per million, keep going up, without at least keeping the capacity we've got and preferably expanding it. But that's an easier thing to say than to do. And I see it only as an undesirable medium term. I would hope in the longer term, but it is longer term, that one will have fusion reaction. That's always been a dream. I mean, it's been true since I was a graduate student that practical power from nuclear fusion was about 30 years away. That's been true for about 40, 50 years. And I would hope that would happen. And I would hope there are lots of other things. And there are things that fashion drives too much of it. So, and any way there is, once it comes on stream, then people object to it. So you start building wind farms, and then people don't want wind farms because they're unsightly. And one of the things I personally can't understand, that's probably something about me, is the analogue in the water of wind farms is to put wind turbines on the bottom of the in tidal estuaries so that there's no problem of whether it's windy or not, because the tide goes in and out every day and drives turbines. That's just a technology that never took off. I don't understand why. It's different from the barrages that have been proposed and so on. So geothermal is extensively used in Iceland and New Zealand, but the reason we tend to forget that the reason that the Earth didn't totally freeze several billion years ago is there are radioactive decay processes going on in the Earth's interior that have kept the Earth at the temperature it is. And if you go down deep enough, there's a sort of built-in form of nuclear energy that manifests itself as geothermal. There are various other things like that, of using salinity as an energy source going down, that undoubtedly when people get round to looking at them will have serious problems. But the fact of the matter is we've just, for the last several centuries, done the easy thing, and there's a huge amount of conservatism and inertia into not wanting to go beyond it. And I mean, the other thing I would add to that, one of the best analyses of what we could be doing to be effective is a paper that was published by Pacala and Sokolow in Science 2 years ago, in which they listed some 15 things based on current technologies, which if we began actively doing now to bring fully on stream by 2015, if you took any 7 of these 15 and really actively implemented them over the next decade, all of them with proven technologies, you would be able to bring things by the middle of the century to hold it level at somewhere like 500 parts per million, which is not real great, but is better than looking to see it going there and then just still going up. And some of them are. One of the wedges is doubling nuclear power. Others are, but they fall in 4 categories, and no single one of them will do it. One of them is just adapting to change, like in Holland, beginning to build houses that are designed seasonally to float, because Holland is, I think it's either 30% or 70%, it's probably 30% is actually below sea level. And as things rise and there's more runoff, they're going to flood some of the polders seasonally on houses that float. So we could be doing it by implementing now instead of talking about it. Stricter rules on not building on floodplains, which we're still doing, because by and large they're not, they're sort of cheap and they're the things you can do. So one of the things is adapting. Another of the things is being less wasteful. And there are many studies that show you can operate a house, if it's properly insulated and various other things are done, that sacrifices no present amenities and uses 40% of the energy. And then another, of course, is sequestering the carbon at source and storing it. And that's somewhat more, there are technologies that do it, but to do it effectively, you're never going to sequester all of it, and do it effectively is a bit more futuristic, but that's something clearly seeing as that's the major source and going to become even bigger, burning coal. And finally, it's the whole raft of renewables, not just the ones that are currently fashionable, but the whole suite of things involving, amongst other things, newer approaches, some biology-based, some physics-based, to solar power.
Everybody complains about the nanny state, but I mean, to tackle the sort of problems you alluded to now, we're going to need a highly regulated society, aren't we? I mean, the free market, can it cope with the sort of challenges that lie ahead to implement the changes we need? I mean, isn't it a desperate situation?
Well, my view is that the question, nannies can be good or bad, and it's a great phrase because it's so emotionally loaded, but many of the children I observe on buses these days, I feel could have benefited from an appropriate kind of nanny early in life. My own view is we have a system which in many ways is inappropriately intrusive, and I would like to, and I suppose we all would, but it's just then we'd quarrel about what we mean by the word appropriately. I believe we need an appropriately intrusive state. Interestingly, I mean, at the heart of all of this is one of the great unsolved problems of understanding the world and ourselves, which is how we ever evolved large, cohesive, cooperative aggregates. And the glib answer is, well, if there are advantages to doing it and there are small costs associated with cooperative behavior, obviously it pays to do it. But that's susceptible to the free rider. It's various names it has: prisoner's dilemma, tragedy of the commons, free rider, the person who enjoys the benefits but doesn't pay the dues. And that's still an unsolved problem. And my own personal view is that one of the mechanisms that facilitated it, and this is now becoming just cocktail party chatter, one of the things that facilitated it was creating hierarchical structures of obedience and authority that came with an attractive belief system that motivated the recognition that here were the people who spoke for the Almighty and told you what to do, and were endowed with that authority, and it made for a society that could function in large and complicated ways, but it has the property, which is another inherent paradox in evolutionary biology. There's a more general thing that's inherent in what I think of as the analogue of Newton's second law. I mean, the analogue of Newton's, this is getting very technical, the analogue in biology of Newton's first law, which says bodies tend to remain in their state of rest or uniform motion in a straight line unless they're disturbed, is Hardy-Weinberg, that says gene frequencies don't change in the absence of selection, migration, statistical fluctuations, which in its time was really important, because just as people didn't really understand Newton's first law, so for Darwin it was difficult because people believed inheritance blended characteristics and that would have washed out the variation. Hardy-Weinberg says gene frequencies don't change. And then Newton's second law, force equals mass times acceleration, describes change. The analogue of that in biology is Fisher's fundamental theorem, which says there's a tension between if things change, then the rate at which you can adapt to a changing environment is proportional to the variance in the gene pool, the amount of variability you've got to work on. But there's a tension there, because for a particular environment, you're going to be most effective if everyone's adapted to it. But you do that, and then things change, and it's bad. And that's a tension we see all through history of life on Earth. But you can actually apply something like Fisher's fundamental theory to the problem of, if it is true that one of the essential mechanisms that makes for cohesion in human societies is respect for apodictic authority that tells you, this is the legislation, or this is what he said, or she said. Well, it's always he said. Then it's very hard to change, because such hierarchies are very resistant to change, and we see that. And we see in all those abstract metaphors we see playing out. Nobody wants to. Global change is something we all need to act on, but it'd be much better if everybody else did except us. So ExxonMobil doesn't want to change, and so it says it's not going to do anything until China does something in proportion. I don't know what the answer is, but I do believe it is a mixture of appropriate authority, and the key property of the appropriate authority is it's willing to look honestly at the facts and recognize the need for change. And I'm not sure that that's what the typical nanny will always do.